Hello and welcome to ICND2 Lab 9, PPP and CHAP configuration. For those of you using the Cisco Press exam certification guides, note that the material covered in this video is also covered in the ICND2 books Chapter 12.
There are four main objectives you can achieve by watching this lab. First, you'll be better able to configure PPP, as well as you'll be able to better describe the meaning of the two interface status codes. You'll also learn how to configure CHAP, and in particular you'll see how CHAP does not send the clear text password across the link when authenticating a link.
Lab 9 uses two main scenario steps.
In the first step, you'll start with a working HDLC link and migrate from using HDLC to PPP. In the second scenario step, you'll add PPP CHAP configuration to the link and prove that the link can be authenticated with CHAP. Next, we'll go ahead and start step 1. In step 1, we'll use a simple two-router network with R1 and R2 each having a fast Ethernet 00 interface with the IP addresses you see there. Additionally, there'll be a point-to-point serial link between the two with addresses 172.16.2.1 on router 1 and 2.2 there on router 2. So we'll end up with three subnets. In this case, we'll use a nice easy /24 mask for each of the three subnets, so we'll end up with the three subnets that you see there on the screen. This lab step focuses on what it takes for a serial interface to be in an up and working state. Now with Cisco IOS, each interface has a two-part status code that states whether or not the interface is up and working. For an interface to be working, both status codes must be up. Before looking at the command line interface for the serial link, let's look at the four combinations of those two status codes which you might bump into in an actual router. First of all, if you've had a shutdown command configured on the interface, then the first status code shows administratively down, and the second status code lists simply down. So that just means that you shut down the interface. Now if you've put a no shutdown command on the interface, but there's a layer 1 problem, say the cable's not installed, or it's the wrong cable, or there's no signal on the line, then the first interface status code will be down as well as the second. So it'll be down and down, if you will. Now if you get the layer 1 problems fixed and you have the right cabling installed, but there's some kind of a layer 2 data link layer problem, then the status code will probably be up in the first status code and down in the second status code. This up and down state is often caused by data link layer configuration issues, two of which you'll see later in this video. If you overcome the layer 2 problem, then you'll finally get to an up and up state, which means the interface is working. So, as you can see from the table, the first status code relates mostly to layer 1 issues, and the second status code relates mostly to layer 2 issues. Because of that, it doesn't make sense to see a status code of down and up, meaning layer 1 is down but layer 2 is up, because layer 2 can't do anything until the underlying layer 1 facility can pass bits. This step begins with both R1 and R2 fully configured, except R1 has a shutdown command on its serial interface. So if we go to R1's command line interface and do a show interface as serial 0/1/0 command, we look at the very first line of output, we see both status codes listed. The first status code, called the line status, says that serial 010 is administratively down, meaning it's been shut down. Now that really relates to layer 1 issues, so the layer 1 facilities aren't working. So the line protocol status, the second line status, which refers to layer 2 issues, is also down because layer 2 can't do anything if the underlying layer 1 facility is not working. Now that's one way to see the status of the interface. You can also do the show IP interface brief command that you see here. If we look there, we get one line apiece for each of the interfaces. If you look at the highlighted line, we notice that we're administratively down still on interface serial 010. Next, we'll bring up the serial link by doing a no shutdown command on the interface. So first we'll use the configure terminal command to get in configuration mode. Then use the interface serial 0/1/0 command to get into interface configuration mode. And then use the no shutdown command to bring it out of shutdown mode. So if you wait just a few seconds, we'll see a message show up here. Notice it says line interface change state to up. That's the line is up, layer 1 facilities if you will. Then it says line protocol has changed state to up. Both of these log messages show up telling us that the interface came up. Now if we get out of configuration mode and repeat our show IP interface brief command, and you look now at serial 010, notice it says the line status is up and the protocol status is up as well. HDLC is the default data link protocol on serial interfaces on Cisco routers. Next, we'll migrate the configuration to use PPP, and along the way, we'll see the interface end up in an up and down state. To configure PPP, we'll once again get into configuration mode, type the interface serial 010 command, and then use the encapsulation PPP command that you see highlighted here. Now by using this command, we're simply telling the router to use PPP as the data link protocol in the serial link. So once we press enter, the router says, okay, I'm going to try PPP. Now router 2 on the other end of the link is still using HDLC. So that means the data link protocols are mismatched, and that means layer 2 can't work. So notice the log message that showed up that says line protocol status has changed state to down. So the second of the two status codes should now be down. If we get out of configuration mode and repeat the show IP interface brief command, notice now that we're in an up and down state on the serial link. To solve this problem, all we have to do is switch over to router 2 and complete the configuration. Once on router 2, if we get into configuration mode with the configure terminal command, type the interface serial 010 command to get into interface config mode, and as we did on router 1, and type the encapsulation PPP command, now we've told router 2 to use PPP on its serial link as well. Now if we switch back to router 1 and do the show IP interface brief command again, notice now the serial link is now in an up and up state, which means the serial link is successfully using PPP. Next we'll move on to step 2, which shows how to use PPP CHAP. CHAP is an authentication feature which allows two routers to verify that the router on the other end of the link is indeed a router that should be on the link and should be trusted. To authenticate, CHAP uses three messages. The first message that you see here is called the challenge message. This message lists R1's host name along with a random number that R1 makes up. Router 2 replies to that with R2's host name with an MD5 hash. MD5 stands for message digest, and it creates a hash value based on a mathematical function. Now notice, the random number goes in the first message, and this hash goes in the second message. Neither of those are a clear text password. Both R1 and R2 will know a clear text password, but they'll never send that in the open, so that it's much less likely that somebody could break into this authentication process. Once the second message gets back to R1, R1 can verify whether the process worked or not and send either a success or failure message. Those are the basics of CHAP, but next we'll take a much closer look at the process. First of all, in R1 we'll have configuration that lists R1's hostname of R1 as well as a username command that refers to R2. Notice it says username R2 password depth. That will be the password used for this authentication process. R2 has very similar config with R2's own hostname configured and a username command referencing over to router R1 with the same password. If the passwords aren't the same, then the authentication will fail. So R1 makes up a random number, as we talked about a few moments ago, creates a challenge message, and fills it with its host name based on the hostname command and a random number based on a just random number that R1 makes up. Once R2 receives that challenge message, R2 needs to calculate that MD5 hash. Well, that's a mathematical function that uses a random number in the challenge message as part of the input, and the password is the other part. To know the password, R2 is going to take the host name that was listed in the challenge message, R1 in this case, find the username command with R1 in it, take the password in that same command, and feed it into the MD5 hash function. At that point, R2 will have calculated the MD5 hash. Next, R2 needs to build its response message. He puts the hostname in based on R2's hostname configuration command, and the MD5 hash value based on the formula that it just calculated. Now once R1 receives this message, R1 wants to do the same math that R2 did. So R1 will take a look at the response message's hostname, which says R2, find R1's username R2 command to find the password. He'll feed that password into the MD5 mathematical formula. Also, it'll use the random number that R1 had already generated. R1 doesn't need to see that in the response message because R1 made up that random number in the first place. So essentially, R1's doing the exact same math with the exact same two input values as R2. So if R1 comes up with the exact same answer to the MD5 hash math, then there's a success, and we can send a success message back over to router 2. However, if R1 calculates a different value, then R1 must have used a different password value than R2, so they aren't using the same passwords, so the authentication should fail. Next, let's take a look at the command line interface. I've already configured router R2, so let's take a look at the configuration for router R1. First, we need to use the configure terminal command to get in configuration mode, and then we need to create the username command. The username command is going to list R2 as a host name, but in this case we're going to give a password of height. Now R2's got a password of depth configured, so of course the passwords are different. So we're going to do that first just to show what happens when the PPP authentication fails. Now in addition to the username command, R1 already has a hostname R1 command. You can see the command prompt there with R1 as a nice reminder of that. And there's one additional command you need to use. It's an interface subcommand, so we'll get into interface configuration mode by typing the interface serial 010 command, and then use the command PPP authentication CHAP, as you see there. That command actually enables the CHAP process on the interface. So once that's configured, we can get out of configuration mode, and if we do a show IP interface brief command, and we look down here at serial 010, notice it says that the line is up, but the line protocol is down. So that means that the physical media, the layer 1 details are working, but the layer 2 details are not working. The reason layer 2 details aren't working right now is the two routers have a different CHAP password as defined in the username command. To fix this problem, all we have to do is change the username command on R1 to have the same password as R2 and redrive the CHAP authentication process. To do that, we'll get into configuration mode using the configure terminal command, and then we'll retype the username command, username R2, but this time with password depth because that's the same password that's configured over on R2. Now if you wait around long enough, the link will come up. However, to redrive that process, we'll get into interface serial 010 configuration mode, and while there we'll use the shutdown command to bring down the interface, and then the no shutdown command to bring it right back up again. By doing that, it's going to cause the router to bring up the interface, which includes the CHAP authentication process. Notice there we see the message that tells us the line has come back up. Also, if you do the show IP interface brief command now, notice the highlighted line here shows that serial 010 is indeed, again, in an up and up state because the CHAP authentication process has completed.
This concludes ICND2 Lab 9. In this lab, you've learned how to configure PPP as well as how to describe the meaning of the two interface status codes. You've also learned how to configure CHAP, and you've heard an explanation as to why CHAP does not send the clear text password over the link but can still authenticate the endpoints.